So we're going to go over graphing, or we're going to start graphing rational functions today. We are not going to do actually graphing. We're just going to identify parts of it. So a rational function, we've talked about before, it's a function that's a fraction where the numerator and the denominator are polynomials. So the numerator and the denominator both have x's in them. So here's the graph of x plus 3, x plus 2. I will also be using a highlighter today. Well, I would be if I was actually highlighting, but so the domain of a rational function includes all real numbers except numbers that make your denominator equal 0. So as we look at this equation, we'd find what numbers make our denominator equal 0. We're going to set our denominator equal to 0. So x plus 2 equals 0. And then we solve this, so we get x equals -2. So then we state the domain. So your domain is all real numbers except -2. And mathematicians are lazy people, so we have a symbol for all real numbers. It's like the R with the paragraph symbol.
What is
That's the symbol for all real numbers.
So it's an R with an extra bar.
Yeah. So you make a bar, then you make another bar, and then you draw an R. Boom. Okay. Now our function also has vertical asymptotes at the zeros of our denominators. So what makes our denominator equal 0? Well, we found that. That's at x equals -2. So we have a vertical asymptote at x equals -2. Now an asymptote is a kind of like an invisible line that your graph will not cross. So a vertical one would be a vertical line that your graph does not cross. So if you look here, you have a vertical asymptote at -2. And again, we got that from where our denominator equaled 0. All right. So what we're going to do is we're going to practice some of these, identifying our vertical asymptotes. So we're finding the vertical line that our graph, the imaginary or invisible vertical line that our graph does not cross. So on A, looks like it is at 1. So at x equals 1. This is normally where I'd use a highlighter on the graph, but EduCreations does not have a highlight option.
lame?
I know.
You should see.
Well, technically I haven't paid, because I use a new card every year for it, and so they keep charging the old card, so I'm technically using this for free. Yeah, I'm recording. It's not like they're going to actually watch it.
I'm gonna send this to Edu too.
Yeah, go for it. B, the vertical line that our graph does not cross, it gets super, super close to, but never crosses, is at 0. So x equals 0 is the vertical asymptote on B. On C, I have 2 vertical asymptotes. I have one at x equals -2. And one at x equals +3. So now what we're going to do is we are going to match the graphs to the rational functions. So what we're going to do is we are going to find the vertical asymptotes from our equations here. There's some lag going on right now. And then match it to the graph. So your vertical asymptotes is where your denominator equals 0. So I set my denominator equal to 0. So I have a vertical asymptote at 0, which matches up with B. On 2, what numbers would make my denominator equal 0? Well, my first parenthesis, that would be 3. And my second parenthesis would be -2. So this matches up with graph C. And then on 3, number that makes my denominator equal 0, that would be 1, which matches up with graph A. So we're going to pause for 5 minutes here, and I'm going to let you work on the front part of your homework worksheet. It is matching the equations to the graphs. All right, so all we're going to do is practice these a little bit. To find the domain of the vertical asymptotes. So again, your domain is numbers that make your denominator equal 0. So I set my denominator of x plus 2 equal to 0. And I solve it to get x equals -2. So your domain is going to be all real numbers except -2. And our vertical asymptotes would be at x equals -2. For 5, we need to factor that denominator first, so the x squared minus 4. So to factor it, we're going to factor using difference of squares. So the x squared minus 4 will factor into an x plus 2 and an x minus 2. And then we have to identify what numbers make them equal 0. So the first parenthesis, for it to equal 0, it would have to be an x equals -2. And for our second parenthesis, for that to equal 0, it would have to be an x equals +2. My iPad will maybe catch up here with the... There it goes. Maybe. So your domain is always all real numbers except those numbers that make the denominator equal 0. So here would be -2 and +2, which means we will have 2 vertical asymptotes. We'll have a vertical asymptote at x equals -2 and a vertical asymptote at x equals +2. Six, I don't have anything to factor, so I'm just going to set my denominator equal to 0. So x squared equals 0. And then to get rid of the squared, we would take the square root of each side. So when I take the square root of each side, I get x, square root of 0, it's just 0. So again, your domain is all real numbers except numbers that make the denominator equal 0. So this will be all real numbers except 0, which means my vertical asymptote is at x equals 0. Seven, the method of factoring I'm going to use on the denominator is greatest common factor, so GCF. And on that denominator, I can factor out an x. So when I factor out an x, it leaves me with an x plus 3. So numbers that would make that factored form equal 0, to make the plain x equal 0, that would just be x equals 0. And the x plus 3 to equal 0, I'd need x to equal -3. So my domain is all real numbers except 0 and -3. And my vertical asymptotes would be at x equals 0 and at x equals -3. Eight, method of factoring I'm going to use on the denominator will be factor sum. So I'm looking for factors of 3 that have a sum of 4. So two numbers that multiply to 3 and add to 4 would be 3 and 1. That's an awkward 3. So this would factor into an x plus 3 and an x plus 1. So then to make my denominators equal 0, my first parenthesis would have to be an x equals negative 3. And my second parenthesis would have to be an x equals negative 1. So my domain is all real numbers except negative 3 and negative 1, which means my vertical asymptotes would be at x equals negative 3 and x equals negative 1. On 9, to factor the denominator, we'd either have to use SAM or grouping. So because of the 2 in front, so we find factors, we have to multiply the 2 times the negative 3, so we're finding factors of negative 6 that have a sum of negative 5. So two numbers that multiply to negative 6 and add to a negative 5. That would be negative 6 and 1. So when I factor this, because of the 2 in front, I'll have a 2x minus 6. And again, because of the 2 in front, I'll have a 2x plus 1. Don't forget to reduce. So I could reduce that first parenthesis by 2. So that this will become an x minus 3 and a 2x plus 1. So to figure out what numbers would make my denominator equal 0, for my first parenthesis, it would be 3. For my second parenthesis, I would have to subtract 1, so I'd get negative 1, and then divide by 2. So I'd get negative 1 divided by 2, which is negative 1/2. So my domain is all real numbers except 3 and negative 1/2. So my vertical asymptotes are at x equals 3 and x equals negative 1/2. So for our horizontal asymptotes, here's the same graph that we started with, the x plus 3 over x plus 2. So do we see a horizontal asymptote? So same thing as vertical, but horizontal. At y equals 1. Let's do this in purple. It doesn't really touch it. It just gets so close that it's hard to draw it getting closer. Does that make sense? Like it's just like the pixels of things and. Come on. So it's at y equals 1, and eventually my iPad will catch up to. All right. So to determine your horizontal asymptote, you have to look at the exponents, or the degrees, on your function. So the first type that can happen is our numerator can have a smaller degree than our denominator. So the exponent on our numerator is less than the exponent on our denominator. So this would be something like x squared over x to the 7th. Because the degree on the top is smaller than the degree on the bottom. So anytime this happens, your horizontal asymptote is always y equals 0. So anytime the biggest exponent on the top is smaller than the biggest exponent on the bottom, it is always y equals 0.
That is 7.
Yep. X to the 7th. X squared over x to the 7th. I'm going to jump to the bottom one. So now, if the degree of the numerator is greater than the degree of the denominator, so the exponent on the top is bigger than the exponent on the bottom, So this would be something like x to the 7th over x squared. So if we notice the exponent on the top is bigger than the exponent on the bottom. Anytime this happens, we will have no horizontal asymptote.
Is there an abbreviation for that?
I would just write no HA. There's no like special. Now the tricky one, well not super tricky, but is if they are the same exponent. So if the degree in the numerator equals the degree in the denominator. So they have the same exponent. So something like 5x squared over 4x squared. They are both x squareds. Whenever this happens, you're going to take, let's change to green, the leading coefficients, so the numbers in front. So our horizontal asymptote here would be at y equals 5 over 4. And if we go back to the top of this page where we look at the graph, here notice that both of these are x to the first, so they are the same. So really what we're doing is taking the numbers in front, which is a y equals 1 over 1, or just 1. So we'll practice some of these. You need to identify which one's bigger, the top or the bottom, or if they're the same. So on number 1, x cubed over x squared. Here, the numerator is greater than the denominator. Okay, the numerator has a bigger exponent. It's 3 on top, and that's bigger than 2 on bottom. Anytime the numerator is bigger than the denominator, there is no horizontal asymptote. We do not have one. On number 2, we have an x to the first power over an x to the first power. So they are both the same exponents. So here the numerator equals the denominator. And whenever that happens, we take our numbers in front. So this would be a y equals 2 over 1, which is just 2. Three, I've got an x to the first on top and an x squared on bottom. So here the numerator is less than the denominator. The bottom has the bigger exponent. Whenever the bottom has the bigger exponent, your horizontal asymptote is always at y equals 0. Four. When we try and compare which one has the bigger exponent, we have to notice that there's not an x on top, so it's like an x to the 0. And the exponent on the denominator is 1. So again, here, the numerator is less than the denominator. And whenever that happens, our horizontal asymptote is always at y equals 0. Yes?
Quick question. On number 3, if you had like x squared plus, let's say, x over x squared plus x to the 3, would you add the exponents on both?
No, you only look at the biggest one. So it sounds like the biggest one on top is a squared and the biggest one on bottom's to the third. So then it would be 0 because the bottom's bigger. All right, so now we're going to put it all together. So to find your domain and your vertical asymptote, that's you take your denominator and set it equal to 0. So x plus 2 equals 0 would mean that x equals negative 2. So your domain is all real numbers except numbers that make the denominator equal 0, which would be negative 2. It would also be my vertical asymptote would be at x equals negative 2. And then to find your horizontal asymptote, you look at the biggest exponent. So this is an x to the first over x to the first. So here, the numerator equals the denominator. Whenever that happens, we take the numbers in front. So our horizontal asymptote would be y equals 1 over 1, or just 1. On 6, we need to factor our denominator first. So we would use a factor sum. We'd be looking for factors of -3 that have a sum of +2. So two numbers that multiply to -3 and add to +2 would be a +3 and a -1. So this would factor into an x plus 3 and an x minus 1. And again, we need to find where these numbers would make, what numbers would make this denominator equal 0. So this would be at x equals -3 and at x equals +1. So my domain is all real numbers except -3 and +1. And my vertical asymptotes would be at x equals -3 and x equals +1. To find your horizontal asymptotes, you have to look at the exponents. So the biggest exponent on the top is 1, and the biggest exponent on the bottom is 2. So the numerator is less than the denominator. And whenever that happens, our horizontal asymptote is always y equals 0. So anytime the bottom is bigger, our horizontal asymptote is at 0. Seven, to graph, to find our domain, we need to factor out our denominator. Our method of factoring on our denominator would be GCF. So we factor out our greatest common factor on our denominator, which would be an x, which would leave me with an x minus 4. So numbers that would make our denominators equal 0 would be at x equals 0 and at x equals +4. So my domain would be at all real numbers except 0 and 4. So my vertical asymptotes are at x equals 0 and at x equals 4. To find your horizontal asymptote, you look at the exponents. Which one's bigger? The numerator is 3 and the denominator is 2. So the numerator is greater than the denominator. And whenever that happens, we do not have a horizontal asymptote. There is none. The last ones we are just going to identify based off the graph. So our horizontal asymptotes. Okay. It's easier to look at the left and the right. So here, my horizontal asymptote is the horizontal line that your graph gets really close to but doesn't cross. This one would be at y equals 0. The vertical asymptote is the vertical line that your graph gets close to but doesn't cross, which would be at -3. So this would be x equals -3. So number 9, your horizontal asymptote here. Now, we will go over this more tomorrow, but you're allowed to cross your horizontal asymptote in the middle.
So it can cross
For horizontal, yes. It's allowed to cross in the middle somewhere. So here, when we look at this, our horizontal asymptote would still be at 0, even though it's crossing right there. Your vertical asymptote, here we have 2 vertical asymptotes. So we have one at -2 and +2. So x equals -2 and x equals +2. And then our last one, our horizontal asymptote. Again, it's easier to look towards the ends to help you figure out where it is. Would be at y equals +3. And on this graph, your vertical asymptote is a little bit ambiguous. I would not make it ambiguous on a test. But here, nope, when we graph it, it should be at -2.